assignment, okay? The biggest thing I needed you to remember from inverse functions is how we find the inverse, okay? No matter if it is numerically, graphically, or algebraically, there is one way to find an inverse. And that is by doing what? Okay? It is just a matter of switching x's and y's. Okay? Whether it's numerically switching x and y, like in a table, graphically taking our xy coordinates and flipping them to where we have a new graph, or algebraically, where we literally take x and y and switch places and then solve for y. Okay? Now, something that you probably didn't talk about, or maybe you just like grazed over in Algebra 2, but this does include domain and range. Okay, so that's something you maybe want to take note of. Whatever our domain is for our function, it will become the range of our inverse. Whatever the range is for our function will then become the domain of our inverse. Okay, what?
How'd you know to solve domain and range then?
Exactly, right? So if you know the domain and range of your original function, boom, you have it for your inverse. You don't have to think about it again, okay? Which is kind of nuts, isn't it? Maybe, just a little bit, okay? All right, so a couple things I want to talk about that would not have been on your green sheet, okay, is the horizontal line test. Okay, we have a vertical line test, don't we? Okay, and the vertical line test, what does it test for, Jacob?
To see if there's 2 points that touch horizontal.
Okay, and if on my vertical line it goes through more than twice, what does that mean?
It's not a function.
It's not a function, okay? So our vertical line tests to see if it's a function. Our horizontal line test, same principle, does it go through more than once? Our horizontal line test tests to see if an inverse exists. Okay? So if we have a graph that a horizontal line would go through more than once, then when we switch all of the x's and y's, it's not going to be a function anymore. Let me give you an example. Does this graph pass the horizontal line test? It does not. If we draw a horizontal line, it goes through more than once. Okay? It's a function, but it doesn't pass the horizontal line test. So let's go ahead and find what our inverse graph would look like. Okay? So I'm just going to point out coordinates, and we're going to switch x and y. So this is the coordinate 0, 0. When we switch x and y,
0, 0.
that's so boring. Okay. Oh well. This coordinate is 1, 1. Okay. Let's get a little bit more exciting. This coordinate is negative 1, 1. So it becomes 1, negative 1. This coordinate is 2, 4. We flip it, it becomes 4, 2. This coordinate right here is negative 2, 4. We switch x and y, and it becomes 4, negative 2. So here would be the graph if we switched all of our x, y coordinates. Okay? Well, what's true about that green curve? It passes the horizontal line test, but what does it not pass? It doesn't pass the vertical line test. So because this blue function failed the horizontal line test, it means the inverse is not going to be a function. Okay? The green passes the horizontal line test. Okay, so when we have a graph that passes the horizontal line test, and then we find its inverse, and the inverse is a function, we call that function one-to-one. And you're not going to hear this super often, but I at least want you to know what it means. Okay? A one-to-one function means there is one input per one output. So not only is it a function, but there is only one input for each output, one output for each input. Okay, but you could read it either way. It passes the horizontal line test, it passes the vertical line test. Okay, an example of a one-to-one function would be y equals x cubed. Okay, it passes the vertical line test and the horizontal line test. So it is a function and it has an inverse that's a function. Okay, so we say that it's one-to-one. All right, let's get to the algebra of all of this, because that's really what's the most intense of it all. Okay, I can give you a table and you can switch x's and y's without a lot of thought. I could give you a graph, you can identify coordinates and switch x's and y's. Okay, but let's talk about the algebra, because we have a variety of techniques that we're going to have to use when we find these algebraically. So first of all, this was number 2 on your green worksheet. Okay, go ahead and if you didn't already, compare the answer real quick with your neighbors. What is the answer that you got?
I just wrote it.
Okay, so before we get to the algebra and kind of checking your work from the weekend, let's talk about the domain and range. This is a line, 3x minus 9. Use kind of our function aerobic stance here. What's the domain of a line with slope? Okay, all real numbers. In interval notation, right? What about the range, the y values? Okay, look at my arms. What would the range be of a line with slope? Also all real numbers. Okay. I'm identifying the domain and range of my original function. So then when I get to the inverse, I don't have to think about it. I can just switch it. Okay, we know the domain and range of the inverse at this point. Okay? All right, so help me out. Eli, what's the first thing you did?
Switch x and y.
Switch x and y. So f of x is the same thing as y. So we are going to switch x and y. But then I want you to solve for y. Okay, so in order to solve for y, get y by itself. Kenshi, what step can we take? You put 0 in for x? Okay, so we don't actually want to plug anything in because we want to keep it an equation. Okay, we want to keep the x's and y's there. So instead of plugging numbers in, we just want to take this equation and we want to get y by itself. So we need to be able to move everything else to the other side. So should we move the 9 first or the 3? Okay, so we can add the 9 first. Okay. Then, since the 3 is the only thing left, we can divide it over. Okay. Now, since this is a linear equation, I would rather see this written as a line. So, I would rather you see y equals 1/3 x plus 9 divided by 3 is 3. I'd rather see you break that apart. Okay. And since I'm looking for an inverse, okay, using inverse notation, we could write f inverse of x is 1/3 x plus 3. okay? And this part isn't very exciting because our domain and range is the same. But when we have our inverse, the range becomes our domain, and the domain becomes the inverse range. We don't have to think about it. Just switch it. Okay. Now, the linear ones, probably not something that I'm going to ask on a test, right? You've been working with linear inverses maybe even since Algebra 1, okay? But at the very least, Algebra 2, you would have had something like this on your test. So that was kind of like our warm-up, right? We got our brain muscles going. Let's talk about that next one that you have. Okay, so before we get into the algebra of it, I want you to think about the transformations of that square root function and go ahead and identify the domain and range of our original function together with your pi. What's the domain and range of our original function?
No, it goes from
Oh, shoot. Yeah, you just. Yeah.
Is this the mental picture that you have? Yeah. Oh, okay. Okay, so this is the mental picture that you have. Okay, Talon, what do you have for your domain? 3 to infinity. And the range. Brecken. 7 to infinity. Okay. And that's our mental picture. You can sketch it really quick if you want to, or you can think about it. Okay? So now, like Eli said in our last example, our first step is to switch x and y. And in order to solve for y, okay, can we square both sides right now? Okay, I would wait until you have the square root by itself, because only when the square root is by itself can you square it and they cancel out. If you square it right now, they're not going to cancel. Okay, so you first need to move that 7 over. Okay. Then you can square both sides to where the square root and the square cancel. Okay. Now that the square root is off, we can add that 3 over. Okay, so I would encourage you to write this as f inverse of x. Okay, you probably don't have this written down, even if you did the problem right, equals x minus 7, the quantity squared, plus 3. Okay, if you got that right, like this algebra, if you got this right this weekend, good job. Okay, if you didn't, that's okay. We have some time to practice tonight, but if you got it right this weekend, be proud of yourself. Okay, and leave it like this. There's no need to multiply this out. Okay, because we like to think of our transformation so we can easily think about how that 7 and 3 are affecting our graph. Now, here's the tricky part. And I wouldn't say that it's tricky, but it's easy to overlook. What did I tell you about the domain and range from function to inverse? They flip-flop. So since the domain is 3 to infinity, the range for our inverse is 3 to infinity. And since the range for our function is 7 to infinity, that becomes our domain. Now, how many of you would have put all real numbers for your domain? I would have, right? There's a quadratic right there. Every time we've seen a quadratic, what has been the domain? So why is it not all real numbers?
Because it has limitations.
Why?
Because the other one had limitations.
Okay, so we started out with this square root function, right? If we take this and we reflect it about that line y equals x, right? This coordinate 3, 7 becomes 7, 3, and we can go all the way to where what happens is we only have half of a parabola. A square root is really only like half of a parabola. So when we reflect it about y equals x, when we find the inverse, we only have half of the parabola. Okay? A parabola doesn't pass the horizontal line test, but a half of a parabola does, so it's safe. Okay? So anytime you have a square root, you're starting out with limited domain and range, which means your quadratic, when you get to the inverse, is also going to be limited for both domain and range. Okay? Which is why I would encourage you to identify the domain and range of the original, so then you don't have to think about it at the end. Okay? All right, should we grade our challenge problem? Okay, I wanted you to just try it, okay? But it was some pretty intense algebra. If you got your inverse to be negative x over x minus 1, that is the right answer. Anyone get that? Negative x over x minus 1. All right, so we all need help with this one, right? Okay. So this is the last one on your green sheet, okay? You can do the work on there or somewhere else, I don't care. But this is probably an important one to write down. Okay. All right, let's talk about its domain. Turn to your neighbor. Tell them what you think the domain is. All right, Devin, what do you think about that domain?
It'd be -1 to infinity and -1 to negative infinity.
Okay, so, and why did you choose -1?
Because -1 would make the denominator 0.
Okay, -1 makes our denominator 0, so we can't have it in our domain. Okay, excellent, thank you. We haven't really worked a lot with rational functions in this class. So instead of talking about our horizontal asymptote rules, which we're going to talk about in chapter 2, let's just worry about the domain of the original. And then when we get to our inverse, we can talk about its domain. Okay, so I'm just going to stop here and let's do the algebra. So when we find an inverse, we switch x and y. So here's our first step. Our x's become y's, our y's become x's. Okay. If you start out with a rational function, aka a fraction, you're probably going to get a fraction as your answer. Okay? But right now we have two different y's thrown in there. Not really something we work with a lot. Okay, so let's talk about some ways to help. So what is like one thing you would do right away?
Multiply by the reciprocal.
Multiply by the reciprocal? Okay, of the denominator. Is that what you're saying? Okay, let's get rid of this fraction. Okay, I don't want a denominator anymore. So let's take, Nathan said multiply by the reciprocal. You could think of multiplying the denominator over, whichever one is more comfortable to you. Let's multiply that denominator over. Okay, well now we don't have a fraction at least. We still have 2y. What can we do with that x?
Distribute it.
We can distribute it. So xy plus x equals y. Now, if we are solving for y, would it make sense to maybe have all of my y's on one side together? Okay, and maybe anything without a y can go somewhere else? Okay, so I'm going to take anything that has a y and keep it on the left side. And then anything without a y, like this x right here, I'm going to subtract over. So I subtracted the y overs to be with the xy. And I took this x and I subtracted it over. Okay. What was the goal of that? Well, look at the left side. Every term on the left side has a what? Has a y. And we are solving for y. So if every term on the left side has a y, we could factor out that y, and now we only have one y instead of two. And in order to solve for our 1y, Veronica, what's our last step? We want y by itself.
Divide the x minus 1 over.
Yeah, just divide that guy over. So y equals negative x over x minus 1. So f inverse equals negative x over x minus 1. The answer I read just a few moments ago. What?
If we just put a negative, we would have solved it always.
Not really.
Because it was a positive x over x minus 1 or x plus 1. If we multiply the entire thing by negative. Oh wait, then that bottom x.
Close. Okay, now we identified this to be the domain of our original, which means we know the inverse is
Right.
range. So we're going to write it down. Okay? The original's domain becomes the inverse's range. Domain becomes range. Okay? And I told you, instead of trying to remember all of our rules for horizontal asymptotes, let's just take this and identify its domain. Okay? Kelly, what number makes our denominator 0?
1.
Okay, so the domain for our inverse is everything but 1. All right, that algebra is a little different than what we're kind of used to, so I think we need to practice this. All right, so I'm going to put an example that's very similar to this on the board, and I'm going to have you work on it at your tables. Before I do that, is there anything that I can clarify for you about the work we did up here? Okay. I'll walk around the room as you work on this, so if you do have a question you want to ask, but you don't want to ask in front of everybody, that's fine, just call me over. But what I want you to do, I want you to take this, maybe on the back of your green sheet, and work together to find me the inverse as well as its domain and range. I'll give you about 5 minutes to do this with your pause. Okay, find the inverse and its domain and range. Okay, we just did a problem very similar, so look at your work you did for the one we just did. Yeah, I would just worry about the function's domain, and then you can just do inverse to help you at the end.
Over here,
X prime wasn't sometimes right
there.
take up
There's two X. And if we go off, so two X.
Yeah.
Well, actually.
You could have to be negative two X.
Yeah, I think if they just divide those together, like.
So the X.
Yeah, so up here in the last bit, we're doing. Okay, so up here, once we got to this point,
And then you can factor out the Y.
we got to this point, we do that next. And you just
Y
range.
minus
Oh,
one
yeah.
plus three.
But then,
No, we factor out the Y.
instead of like trying to factor from here, you're gonna want the y's together.
Yeah.
So it's one times one.
Well, it's subtract, yeah.
And then we can just subtract the 3 out of it, so we have two X minus 3. There's Y times X minus 1.
You can't see you're done?
Just divide it back over.
Divide X by negative 1, X minus 1.
You wanna draw it on both sides?
Sure.
Okay.
Do I want me to show all this?
All the work, yep.
Even like the original?
Yeah, by the door. Yeah, start with where you have like x equals y over.
Like, do you want me to write this too? The original?
yeah, write it up.
This is weird.
I know it is.
so laggy.
Yeah, it's kind of driving me crazy.
So the like the kind of combination of the air maps and just they had just the flying at night shoes like the like mesh on them. They made those, and this is like the second generation of those that changed to like actual shoe material instead of mesh.
Okay, so like the bottom, like looks kind of
It's like air maps. Bottom like
so
air
it
maps.
helps you jump, it helps you run faster. It just
It's just there.
okay. I mean, I like that.
I don't know if I like them. They're okay. Not very comfortable.
Wow. So
I'm more of an Adidas guy. So,
Nikes are really skinny, and Adidas are really wide.
Yeah.
I can't wear Adidas.
I can't see. I think I got everything. But I don't have room, so it's kind of.
No, it looks good. Okay, this is what pod 6 came up with. As I've been walking around, I've also seen answers that look like this. Negative 2x minus 3 over x plus x minus 1. Okay, they're the same thing. Because notice how your numerators are opposite and the denominators are opposite. So really they're the same fraction. Okay? It all just depended on which side you put y's on. So pod 6 put y's on the right side. They thought that was easier. Some of you put y's on the left side. You thought that was easier. It doesn't matter. You get to the same answer. Okay? So we switched x and y. They multiplied the denominator over. They distributed the x through. We got y's to one side, x's to the, y's and non-y's to the other side. They factored out the y, and then whatever was left divided over to the other side. Okay? Their range they identified as negative infinity to negative 2 and 2 to infinity. Negative 2 to infinity. Because their original domain was everything but negative 2. And then the domain for our inverse they identified as everything but 1, since 1 would make the denominator 0. Are there any questions about either their work or your work or the domain or range? Okay, so then while I hand back your quizzes, you are going to take a couple minutes and find me this inverse with its domain and range. I'm going to put your quizzes upside down. Just leave them that way. You don't need to worry about them right now.
What's the domain? Is it
No, it's bracket -2.
That's what it is. minus 2. Sure.
Not minus x squared minus 2.
That's what it is. So, this
You guys have formulas y equals x squared minus 2.
do you guys know what the domain is for me?
It's
Work together.
the original range is your
It's what you're because brackets.
All right, your inverse should be x squared minus 2. Does your work agree with mine? Okay, this one was kind of nice because there was nothing outside here we had to move over. We could just square both sides right away. Very nice. Okay. Emma, what do you have for your domain? And for our range, Sophie, what do you have?
Bracket negative 2 to
Okay. If we think about our parent function from our original, we know that this is a square root function shifted to the left 2. So our domain is negative 2 to infinity. That becomes our range. Our range is 0 to infinity. That becomes our domain. Don't forget about that domain being restricted because we're having half of a parabola from a square root. Okay. All right, so tonight is your last homework assignment for chapter 1. Okay, and a reminder